Hello everyone, welcome back. Let's begin another session in industrial automation. Today you will learn how to program a micro 20 PLC. So this session covers the technical specifications of micro 20 PLC. This is a compact PLC from Allen Bradley. Then you will learn the hardware overview, and then you will learn sourcing and syncing inputs and outputs. Basically, you will learn P type and NPM type sensors and how to interface them with your inputs. And also you will learn how to connect sourcing type outputs in this PLC to drive your pilot lamps. Then you will learn the power supply. Basically, this power supply is a AC to DC converter which drives your micro 20 PLC. Then you will learn a simple program, including timers, counters, contactors, and coils. Finally, we will demonstrate this program in the lab environment, and how to download this code to the PLC will be demonstrated. Technical specifications of micro 20 programmable logic controls is discussed here. So you can see here, this is the micro 20 PLC, which we are going to use for our practicals. So the key features are, they are designed for optimize small standalone machine operations and remote operation projects. So, like from Allen Bradley PLCs, this is the most cost-effective PLC that available in the market for compact design. It has integrated digital inputs and analog input outputs. So it comes with a complete package. You can add additional input output cards to these sockets whenever required. There are some indicators for the inputs and outputs. So pretty much easy, and it supports several communications, example Ethernet IP, Modbus, and it has a built-in real-time clock device, and there's a micro SD card slot. There are many versions available here based depending on your inputs and output types. 5 kilohertz PWM output is also available, which is identical for driving solenoids and valves, sometimes driving for many pulse width modulation applications. In addition to that, this micro 20 remote LCD display is available, but it does not come with this PLC. You have to require it by paying additional amount if you want to use it as a HMI integrated with this PLC. So it is a LCD HMI. It is not supported touch screen, but still you can display pretty much good amount of data for standalone applications. So this PLC is designed for standalone machines and remote automation projects that can be also used for remote terminal unit. It supports Modbus RTU and Modbus TCP. So it has many digital inputs and outputs. So 4 thermistor temperature inputs can be used with this PLC. So the PLC type, you can see here, there are 3 types of PLCs in micro 20. But in our lab, we are using, this is the catalog number of the PLC that is in our lab, 20QBBR. So it has 12 inputs and 4, these are 12 inputs. It can be used for digital inputs, and there are 4 analog inputs. So sometimes these 4 analog inputs are shared with this 12 inputs, which means if we are using 4 analog inputs, only 8 digital inputs are available, because total number is 12, including the analog inputs, 4 analog inputs and 8 digital inputs. There are 7 source type digital outputs. So you have to remember there are sourcing and syncing digital outputs. but this PLC only supports source type digital outputs. And it also has a one analog output which produce 0 to 10 volt output. So this PLC runs with 24 volt DC supply. You have to provide it externally. And so when you want to program it, you need to use the embedded Ethernet port. So your computer has to be plugged with the Ethernet cable to this PLC, and then you can download your program to the PLC using the embedded Ethernet port. So base Ethernet port supports Ethernet IP class version 3 and Modbus TCP. There are serial port which support RS-232, RS-485. Both are non-isolated, which means the ground has to be shared. If you're using RS-232, ground terminals of your serial port should be shared with the external devices for communication. You have to remember there are isolated types communication channels, but this PLC does not support for that. All are non-isolated, which means there is no electrical isolation between the other device that you are sharing for the communication. So additionally, it has CIP serial for Common Industrial Protocol and supports Modbus RTU and Modbus ASCII communications. There are two plugged-in slots. If you can take a look at here. So it has limited inputs and outputs, but for some applications, you might require additional inputs and outputs. So you can you can remove this plastic case in here, these are the two additional plug-in slots. Then you can purchase input and output cards and plug into here. So that will add more digital inputs and outputs to your programmer. And so it has a one output, 10 volt output, which can be used for thermistors or as a output reference. One PWM output, which generates 5 kilohertz, and one micro SD card. So you can use up to 32 GB SD cards. So SD card is can be used for either to save your code or either for data logging. Sometimes you can save your data on SD card. For example, now with the time you can save the temperature or whatever the data comes to your PLC in the SD card as a CSV file. So there are 12 digital inputs and 7 digital outputs. In these 12 digital inputs, as I mentioned, 4 are shared with the analog inputs. So if you're using 4 analog inputs, only 8 digital inputs are available. There are 4 analog inputs and 1 analog output. This PLC is supported with the connected component workbench. And there are 3 supported IEC programming languages. First one is ladder diagram. Second one is function block. Third one is structured text. You can write using any programming language to program this PLC. So you can use user-defined function blocks. And you can use this PLC for PID control. So if you understand the control systems, by using this PLC, it can drive a PID loop. This is the hardware overview of Micro 820 PLC. So here you can see the part number, and every PLC has a MAC address for the Ethernet connection. Basically, you have the input ports here, and the outputs are here. So you can wire them using this screw terminals. This small screw terminal is allocated for connecting your communication channels like RS-232 and RS-485. You have this LED indicators for run, fault, and these small LED indicators are for inputs, and these are for outputs. Now this is the internal view. You can connect this DC power supply to the left-hand side and plug into the your PLC. And here, this is the overall PLC unit. You can plug your SD card module in this slot. And there are some mounting feeds. Either you can mount them on a panel, or behind there's you can mount on it on like a DIN rail. DIN rail mountable as well as this panel mountable. This is your communication ports like RS-232, RS-485. Both are non-isolated. Here, this is the Ethernet port and RJ45 Ethernet connecting port, which can be used for Ethernet communication as well as to program your PLC. There are some status indicators that I have just mentioned. So these LED indicators are just to visualize if the inputs are enabled or disabled. If one input comes, it will display the LED is indicated, and the input is not active, the light is not lit. When the PLC is running, the run status will be lit. If there's a fault, the fault LED will flash out. Sometimes you can force your variables. So in that case, the PLC is at the force states. And when you communicate in the PLC is at communicating states, and SD card slots and output status. So this is the PLC that is available in our lab, 2080 LC20 and 20 QBBR. So it has an embedded SD card slot, which means either you can back up your project file to the SD card and boot it with the program in the SD card, or sometimes you can data log. You can save your data on the SD card when you run in the PLC. For example, your temperature, coil and contact details can be stored as a CSV file, or it can perform recipe functions. Sometimes you can save some data on the SD card, which can be imported when you're running your code as some sort of like a memory. That is called the recipe functions. For communication, this PLC support RS-232 and RS-485 serial communications. So the communication port is over here, which I have just explained you. When you just connect, these are the pins that you have to connect for communication. So that is displayed in here. So pin number 1, you can see here, this is for RS-485 communication, D plus and D minus. Third one is your ground, which is normally supported with RS-232, which comes as pin number 4 is your receiver, and pin number 5 is your transmitter, and 6 is also again a ground. Sometimes this ground can be used for RS-485, and this ground can be used for RS-232. Both grounds are connected internally. And there's an embedded Ethernet port for your Ethernet communication as well as to download your program. This is the typical RJ45 connector. This is pin number 1 and this is pin number 8. Pin number 1 is connected to the TX or the transmitter, transmitting data positive, and pin number 2 is transmitting data negative. 3 is the receiver positive, and 6 is the receiver negative side. So there are some color codings for this RJ45 and the Ethernet wiring. So if you make your own one, you have to follow this. As you can see here in our 20Q BBR PLC, we have the input terminal block and the output terminal block. For example, now this side where you have the inputs, and this is the side where you have the outputs. So they are labeled in this way. You can see here, first we have plus 10 volt, which means this PLC produce plus 10 volt. So which can be taken as a reference 10 volt output. This output basically, although it is in the input terminal, when you measure this voltage with respect to the negative side, this shows 10 volt. And we have minus 24 volt, and here also minus 24 volt and minus 24 volt, three 24 volt negative sides. They are all internally connected. This one is your plus 24 volt, where you provide the positive 24 volt to power the PLC, and you can either use one of these. Normally we can use this one and this one to power up your PLC. And we have up to 11 input channels. This is input 0, 0, and this is input 0, 11. And there are some common terminals, COM0, 4, inputs from 0, 4 to 11. And these are our outputs. This is the only analog output available for this PLC. NU standards for they are not connected to any inputs or outputs. You can have either 7 outputs, digital outputs, starting from 0, 0, 0, 1 to 0, 6. These are the nodes that you have to follow. Minus 24 volt terminal on the input terminal 2 and output terminals 2 and 3. These are, they are internally connected, internally shorted, which means even if you use plug in minus 24 volt here, you can take minus 24 volt out from these two without any additional external connections because they are internally connected. NU means these terminals are not used. Input 0, 0, 0, 1, 0, 2, and 0, 3 are shared between the digital and analog inputs. So you have to note here, although we have 11 inputs, 12 inputs, including the 0, this 0, 0 up to 0, 3, these 4 inputs are basically analog inputs. If you are not using them as analog inputs, you can consider them as digital inputs. That's why they are shared between analog and digital inputs. Either they are configurable as either digital inputs or analog inputs. But these inputs are basically digital. You cannot use them for analog. Input 0, 0 up to 0, 3, they can only be used for syncing input configuration, which means I will explain what is syncing configuration. These 4, since they are dedicated for analog inputs, they are only can be used for syncing input configurations. So this is non-isolated PLC, which means minus 24 volt should not be connected to the chassis of the PLC or the earth of the any channel. So your earth or the ground comes from the power source should not be connected to the minus 24 volt. As you can see here, this is the power wiring for this PLC. First, let's assume we have a DC power supply. So you have to plug AC 24 volts, live and neutral, to these two terminals. And this is your ground, power source ground, which is connected to the chassis or in your panel board. And this AC to DC power supply will convert that AC mains to DC voltage. This is plus 24 volt and minus 24 volt. It is often confused, like even though this is minus 24 volt and plus 24 volt, the difference should be 40. It is not like that. So this minus 24 volt, even though it is considered as that, we consider it as ground. So if you measure the voltage difference, it is only 24 volt. These are some terms normally used in industry. Even though it is mentioned minus 24 volt, actually it is not minus 24 volt with reference to the ground, but you can consider this as your ground. Ground and earth are not the same potential, right? You should not short circuit minus 24 volt with your earth. So as you can see here, this is a DC input, DC syncing input configuration, which means you can wire your PLC for the inputs in this syncing configuration. If you consider the channels 0, 0 to 0, 3, these 4 channels, this is how you can wire them as DC syncing configuration. First, think about like these are push buttons or switches. You have to plug plus 24 volt to one side of the switches, and minus 24 volt should be provided here. If you provide minus 24 volt here, it doesn't matter, they are internally short circuited. So then when you press this, plus 24 volt comes to this channel, and internally it will return back to minus 24 volt through the digital hardware or the analog hardware. So syncing means the current is coming from the plus 24 volt into the PLC, right? It acts as a sync. Now this 4 channels are dedicated for analog and digital. If you are not using them as analog inputs, you can take them as digital inputs. But these inputs, 8 digital inputs, are only digital type. So how to wire them in syncing configuration? First, you have to provide positive side to your switches, and COM0 must be connected to the minus. You have to remember this should be connected to the minus 24 volt for syncing configuration. So when you press this button, the current will come through this path, and it will return internally through the hardware back to your negative side. So again, the current direction into the PLC, which is why we call it as DC syncing configuration. This will not work if you do not connect any minus 24 volt to this COM0. Here also in this channel, this is the common point, which is connected to the minus 24 volt internally. In that case, you don't need to worry about if you're using these 4 channels. Your power supply will carry that 24 volt to here. But when you're using this 8 channel, definitely you have to connect COM0 to the minus 24. In DC sourcing input configuration is shown in this diagram. So you know, like your inputs can also be connected in DC sourcing configurations, but you have to note here, since these 4 channels I00 to I03 are shared between input analog and digital, they can only be configured in syncing configuration, right? You cannot use these 4 as sourcing. They cannot be used for sourcing. They are only syncing configuration, right? So only channels from 04 to 011, these 8 digital inputs can be configured for sourcing configuration. In the sourcing configuration, now the COM0, the common one of the common terminal for all these channels, first should be connected to the positive 24 volt supply. And the other side of the switches should be connected to the negative. So when you press this push button, for example, now current is come to the PLC from the common, and it has to return from the PLC back to your negative side of the power supply. That is why we call that from the PLC end, the current is now sourcing from the PLC. It is going away from the PLC to the negative side. That's why we call it as sourcing. From the channel, it should go to, out from the PLC, not the common terminal, right? So if you consider one single channel, the current is leaving from the PLC. That is why we call it as sourcing. So these 8 channels can be configured either syncing or sourcing configurations. In the syncing configurations, you have seen the common is connected to the minus and plus is connected to the one side of the switch. If you press it, the current comes into the terminal or the channel. That is why it is syncing. In the sourcing, current is leaving the PLC, or the current is sourcing from the PLC. Now, in this PLC, we have digital outputs in this terminal. So there are 2 channels for digital outputs, this channel and this channel. So if you use the first channel, so you have to connect plus PC to plus COM0, which means now this channel is ready for sourcing the current. So you have to note here, this PLC only support output sourcing configuration. It does not have output syncing. It only all the outputs are sourcing, which means if you consider any channel, the current is leaving the channel. So current comes here and through the channel goes to the load and return back to your negative 24 volt. And that should also be connected to your minus COM0. So this is a one single digital output channel available. You can, if you use this channel, you can wire up to 4 digital outputs in the sourcing configuration. Now, if you want to use the second channel, it is the same. So you have to first connect the positive DC to the plus CM1. This is channel 1, and minus 24 volt to minus channel or the common channel into channel 1. Now, these are your loads. If you enable one output, for example, output 04, O stand for outputs and I stand for inputs, right? That is how you distinguish between the inputs and output terminals. Now the current, if you enable this one, the current will go through this channel to your load and return back to the negative side. So this is the output, digital output sourcing configuration. That is the only configuration available in this PLC that we have just discussed. This does not support output syncing configuration. It only supports output sourcing configuration. Now in this page, it is shown how to do the wiring examples. Now, you know, like in this PLC, it supports syncing and sourcing inputs. If you wire the syncing input configuration, the common terminal should be connected to the negative side, and the positive side should go with typically through a fuse. And this is your push button or the switches, and back to your input terminal. So the fuse is used in just a connect case, like if there's a high current goes, it not to destroy your input. So the common is negative, and positive should comes to your input channel when the switch is pressed. So input sourcing configuration, now you have to connect the common through a fuse to the positive side, and when the switch is pressed, the current comes through the common terminal and return from the channel back to your source negative side. This is your push button. So in both configurations, this is the internal hardware of the PLC. It has a high impedance resistance connected parallel with the opto isolator. So these are optical LEDs. So when the current comes through this path, so that will eliminate the transistor, and the CPU will be inform, there's an input signal. Here also the same. This is optically isolated. So that is why, like in this configuration, the current syncing configuration, the current comes to the uh, channel. So that will enable this LED to turn on and return there. That's why we have two LEDs connected in both direction for syncing and sourcing. But you have to remember analog inputs channels from I00 to I03 can only be used for syncing configuration, syncing input configuration, because they cannot be used for sourcing input configuration because they are shared with the input analog inputs. This is the source output wiring example. As I mentioned, this PLC on the support output sourcing configuration. So this is the power source that you have to connect to a particular channel. For example, now here, if you use this channel, channel 1, or the channel, either channel 1 or channel 0, the common plus should be connected to the plus 24 volt, and common minus should be connected to the minus 24 volt, and all channels can be connected to your loads. Now here you can see this is the power supply, which can be connected to the fuse, and then that goes to the bus VDC. This is this side, common plus is connected to the positive 24 volt, and the power supply negative is connected to the DC common or the minus DC volt, the channel 0 minus. If you use a channel 1, it will be the same. Then let's for example, now the output of the channel, it could be any output 00 or output 03 in this channel, or output 04 to output 06 in this channel, is now connected through this line to the load. The load could be the relays or the lamps or any DC load. So if you're using a long wires, you have to use the shielded wiring for noise immunity, and the wire shield can be connected to the protective earth, not the minus 24 volt. It should be connected to the protective earth. So for example, if you want to turn on this load, now from the CPU side, you will get from the CPU end, you will get logic 1 that will turn on this LED in the optical isolator, because your input output channel optically isolated. This is the CPU side. So it provides the logic 1 that will turn on this LED through the optical light. So this transistor will be on, that will turn on this MOSFET. So the positive current coming through this line will go through this MOSFET, through the output, through this line, and energize your load and return back to your negative side. So this is how your current path is completed. Now consider that there's an anti-parallel diode over here. The purpose of diode is basically when you're switching inductive loads. For example, now your load is a solenoid valve, which has a inductive component or a relay. So when you turn on this inductor through the load output channel, the current is flowing in this direction. When you turn off this MOSFET, the current path is now disconnected. So this residual magnetic or the magnetic field created has to be discharged. So the inductor needs to discharge this current. So the way that the current can go back to the inductor is in this way, through the diode, through your output, through this line, back to your inductor. So that is why we using this diode to protect your output channel. Or otherwise, if you do not have this diode, there will be a high voltage spike appearing at your MOSFET that can damage this output channel. Sometimes if this you use like a long wires, sometimes you can use a anti-parallel diode along with your load for additional protection. Otherwise, this diode itself will do some protection, but in the case like where you wire a long wires, it's better to have this diode as much as close to your load. So any inductance in your cables that also act as a cable inductance, so that current can be go through your diode. So there's a less stress for your diode in here, because there's a additional diode here. Now, even if you have resistive loads also, pure resistive load, having long wires, might add additional inductance. So that also acts as a create magnetic field, and it also find a path to return the current that is supported through this diode. If you do not have this diode, when you're having long wires running, that can harm your output MOSFET. That is why we have this MOSFET and the diode to protect your output. Now this is the way that you can wire your analog inputs to your sensors. You know, like here there are 4 analog inputs, I00 to I03. So first you have to connect, let's say this is the sensor 0, which generates the analog voltage. Internally, this sensor has some power, either connected to DC power supply, that will produce some DC voltage, analog signal. That will come to your channel 00. This one is channel 00, and sensor 1 is connected to the channel 1. You can connect up to 4 sensors. And the negative side of your sensor, or the ground of the sensor, should be connected to the minus 24 volt. When you have multiple sensors connected, sometimes it is really difficult to share this minus 24 volt. In that case, you can use a terminal block to common these 4 grounds and then connect it to the minus 24 volt. Now, these are some examples how you can wire digital field devices to your PLC. First, take a look at DC syncing input configuration. Now, this is the PLC side. This is the PLC common, which is connected to the negative of your power supply, or the minus 24 volt. And this is the one particular input channel. So you can see this side is the CPU side, and this is optical isolator. These are used for as like a snubber circuit. So if you have a PNP field device, PNP is a sourcing field device, which means the sensor itself sources the current, which means your PLC should accept a syncing input configuration. If your sensor or the input field device is sourcing, the PLC should be syncing. That is the way that it should work. Now consider you have your field device. So the negative side is connected to the command of the PLC, as well as to the negative of your sensor. And the positive side of the power supply goes to the positive of your sensor. And when the sensor is triggered, for example, if it is a proximity sensor or optical sensor or whatever sensor, if this is triggered by an object or in an event, so the current will go through this BJT to the PLC input. So this is the output of the sensor. So that will go to the PLC. So the PLC is input syncing configuration, which means it is syncing the current. The sensor is sourcing, sensor source the current, and the PLC sync the current. if now the current can go through the optical isolator, that will trigger or turn on the transistor in the CPU side, that will provide a logic 1 to the CPU. Similarly, it is also applicable in the other types of sensors. For example, if you have a NPN type sensor is syncing type. So your PLC should be sourcing input configuration. Now this is a sourcing input module. Now the power supply plus goes to the positive of your sensor, and the power supply negative goes to the negative of the sensor. The power connections are completed. Now you have to make sure the common of your PLC input channel. There could be multiple input channels, but the common is now connected to the positive. Now in the event, if the sensor is triggered, the current will can come through this path, through your PLC, through the optical isolator, and return to your ground, right? So you can see here that the sensor is syncing the current, and your PLC is source in the current. So this is why we call it as DC sourcing configuration of the PLC, and that can only be used for in the event if your field device is a syncing type. Now this is real practical example. We have this 8mm proximity sensor of the type PNP, which is 6 to 30 volt DC. You can connect it to 24 volt DC supply without any issue. The output current, maximum current is 300 milliampere. It is a 3-wire inductive proximity sensor. So we have 3 wires. The brown wire is for positive, and blue wire is for negative, and the black wire is for signal. So if you wire the brown wire to the positive and the blue wire to the negative 24 volt, in the event if the metallic object come close to the sensor, this will turn on the switch that will drive current from the sensor. So that is why this sensor is sourcing current. It source the current. So your PLC should accept or it should be configured in the syncing configuration. The current should sync into the PLC. Now, if you have a NPN type field device, for example, this NPN proximity sensor, it also has 3 wires. Positive goes to the brown, and blue wire goes to the negative. In the event, if the sensor is triggered from a metallic object, the switch will be turned on. Now, your PLC common should be connected to the plus, and your channel is now sourcing the current, and it will make this connection. So field device is syncing, and the PLC is wired to sourcing input configuration. When you have PNP or the sourcing type field device, your PLC should be configured to syncing input configuration. Now think about like this is a PNP sensor. So this PLC, what we have in the lab, has 12 digital inputs. So either you can use all these inputs as digital form, including this analog inputs. So analog inputs, these 4 analog inputs can be configured as digital inputs when you're using it as digital signals. So these 4 all can be configured only for syncing configuration, and these 8 inputs can be configured either sourcing or syncing. But in the event, if you're using it, if you have a PNP sensor, and you have to configure either channels in this syncing configuration based on the channel that you are going to wire this field device. Now, how to do this wiring? First, let's assume like we are using this channel here. First, you have to provide minus 24 volt to this channel and plus 24 volt to one of the switches. Since we don't have any switch, we are just using the sensor, um, connect the plus 24 volt to the sensor and minus 24 volt to the sensor. And the sensor output is taken from here, which should be directly go to one of the channel. Very simple, right? Make sure in the PLC end, you have connected minus 24 volt, is one, and that's it. You don't need to connect any wire to this one because we are not using these switches. Plus to the sensor, minus to the sensor, and the sensor output is directly connected to the one of the any inputs over here. If you use either this inputs from this channel, what you can do is you have to first connect negative to the COM0, and the channel the sensor output can be directly coupled to any of the inputs. So that is how you connect a PNP or the sourcing type PL device to syncing inputs of your PLC. So when you have a NPN sensor, NPN field device, so it is sync-in type. So your PLC input should accept or configured in the sourcing input configuration. These 4 channels are dedicated for analog inputs. They cannot be configured in the sourcing input configuration. Only the channels available for this configuration is these 8 channels in the PLC. So how we do the wiring? First, you have to provide the plus to the sensor and minus to the sensor. The sensor output is here. Okay. In your PLC, the COM0 should be connected to the positive supply, and your sensor output now can directly connect it to one of the inputs. For example, if you connect it to input I06. Okay, so which means the current is comes to the PLC and it will return back from the sensor through the PLC to the sensor, and it will make the power. Right, this is what is available over here. So all you need to do is just connect, take this wire and plug it to one of the inputs in your PLC. You don't need to connect this part. This is not necessary. Only thing is you have to provide this COM0 with plus 24 volt, and the one of the channel can be coupled to the sensor output. So in this PLC, the outputs are only sourcing type. I have explained. So there are 2 output channels. Either you can use both channels. You can only connect for DC loads like lamps, solenoid valves, relays, etc. The COM0 should goes to the positive, and COM0 minus goes to the negative, and the channel output can be connected to any of your DC loads. If you use this channel, common 1 plus goes to the 24 volt positive side, and minus common 1 goes to the negative of the power supply, and channel outputs can be connected to your pilot lamps or the relay. So that is how you connect your DC loads to your outputs of the PLC. Let's see how we can power the micro 20 PLC. Here you need to have a AC to DC converter, which produces 24 volt power to the PLC. So this power supply has to be powered from AC mains. There could be live connect, neutral and earth are connected to the AC mains. Sometimes it is required to use a 2-pole or single phase MCB to disconnect the live and neutral. And the 24 volt positive side should comes to the 24 volt positive side of the PLC power pin, and the 0 volt or the negative side goes to the minus 24 volt line of the PLC. So there are some dedicated Allen Bradley PLC power supplies available. If you purchase them, you can just plug the PLC power supply together with the controller. So you can easily wire this side with the AC mains, and the bottom side is the plus and minus DC voltage that can be connected to the power supply. When it comes to the programming the micro 20 PLC, you need to have a computer where your connected component workbench software is installed. And the computer and the PLC can be directly connected using Ethernet, or else if you have multiple controllers and HMI, sometimes you might need to use a Ethernet switch in the case like if you want to program the HMI and the PLC at the same time. Otherwise, you can just plug the computer with the Ethernet port of the PLC if you're just using the PLC programming. Some computers, modern computers, does not come with the Ethernet port. In that case, you might need to use a USB to Ethernet converter, and the related driver has to be installed in your computer. In that way, any program using ladder logic or structured text or function block diagrams in CCW software can be downloaded to your PLC. Let's take a look at this automation problem related to digital and analog input outputs. There's a PNP proximity switch which is connected to the digital input 0, 1, and NPN proximity switch that is connected to the digital input I04 of the micro 20 PLC. So the instructions are, when the PNP proximity switch is triggered, a pilot lamp connected to the digital output O00 should be turned on. So when the signal comes to the PNP proximity switch through the input I01, the output O00 should be turned on. Similarly, when the NPN proximity switch is triggered, a pilot lamp connected to the digital output O01 should be turned on. Then we NPN switch is triggered 5 times. After a 5-second delay, the pilot lamp connected to the digital output O02 should turn on, which means you might need to use a counter to count the number of events in an NPN proximity switch, and having an additional 5-second timer, and then you have to turn on the digital output 02. So that is basically about the digital inputs and outputs. So you have to carefully wire the PNP and NPN proximity switch to syncing and sourcing input of the micro 20 PLC. Here additionally, there's a 0 to 10 volt analog signal that is fed to the analog input I00, which means input 00, I00 is connected with the 0 to 10 volt analog signal, because PNP sensor is connected to the I01. That is accepting syncing input, and the analog signal also has to be connected to the I00. That particular analog input channels are accepting on the syncing configuration, and whatever the voltage comes to this channel I00 has to be directly reproduced at the analog output Vout0. In micro 20 PLC, we have only one analog output, so you have to measure this voltage comes to the analog input and then copy that value directly to the Vout0, that is the analog output, so which is read the voltage and then copy that voltage, or the reproducing that voltage at this output channel. So let's see how we can solve this problem by writing the ladder diagram in micro 20 PLC, and then after do the wiring and demonstrating. Here you can see the PNP type proximity switch. The brown wire is the plus 24 volt, and the blue wire is a minus 24 volt, and the black wire is for output. Wiring of the NPN proximity switch is the same. The brown wire goes to the plus 24 volt, and blue wire goes to minus 24 volt, and black wire goes to the input. This is our PLC panel board. PLC is connected to the computer using Ethernet cable. Top we have the light indicators, and bottom we have the switches. Here also we have the DC power into the PLC. When we connect in the PNP type sensor, brown wire goes to the plus, blue wire goes to the minus, and the black wire goes to the I01. NPN proximity switch can also be wired following the same color code. Brown goes to the plus, blue goes to the minus, and the black wire goes to the I04 input of the PLC. Here you have to note that COM0 of this analog input channel should be connected to the plus 24. Let's wire the analog inputs. So the PLC 10 volt output is connected to the potentiometer plus, and the PLC minus 24 connected to the other side of the potentiometer. The middle point of the potentiometer can be connected to the analog input 0, 0, as you can see here. Finally, we can complete the output wiring. First, plus COM0 goes to the plus 24 volt, and minus COM0 goes to the minus 24 volt. This is the output channel. The output 0, 0 can be connected to one of the pilot lamps, and so on. We can connect all the three outputs to the three pilot lamps. Once you complete the positive side of the pilot lamps, the negative side of the pilot lamps has to be connected to the minus 24 line. Here we can make common connections between the pilot lamps, and this common connection is connected back to the negative side of the power supply. Let's create the program in CCW. Go to the projects and create a new project. Select the correct PLC and add to the project. Then go to the Ethernet settings and configure your IP address and subnet mask. Then save the project and go to the programs and create a new ladder diagram. And open your ladder diagram. First is our NPN sensor, which is linked to the digital input 0, 1. Then its output can be directly connected to a digital output 0, 0. This is our pilot lamp. So when this is a PNP sensor, we can add comments where required, so that will be easy to follow or anyone reading the program. Next, we can add another rung and add a normally open contact and link to our NPN sensor, which is connected to the digital input 04. And its output is connected to the digital output 01. Then we have to count the number of triggering events in the NPN sensor. In that case, we can add the up counter, which is linked to the NPN sensor. So this counter should count up to 5 times. So the preset value should be set to 5. So its output can be connected to an internal coil. You can name it as any value and set it to a local variable. When the counter is incremented to 5, so it should turn on a on delay timer, which create 5 seconds delay. So now we are going to add the on delay timer. So the preset time has to be configured as 5 seconds. Now the timer output can be connected to a digital output. Go to the global variable and select digital output 02. So our digital inputs and outputs are completed. Now we have to use the analog inputs. So the move function can be used for that, copying the input to the output. Analog input 01 is selected and its value is directly copied to the analog output 00. Now our program is completed. We can build it and see whether there are any compilation errors. Now it is showing like no errors. Now we can download this program to the PLC. Go to download. Then download with project values. So now the program is ready to download. So it is downloaded now. So it is asking to proceed. Click yes. Now the program is in run mode. So you can see that how this code is running in live stream. When the input 1 is triggered, the output is energized. You can see that is the our PNP sensor. So when the NPN sensor is triggered, the output 1 is energized and the number of count is increased to 5. The counter output will turn on the timer, and the timer, after 5 seconds delay, it will turn on the digital output 2. And whatever the analog values comes to the analog input 00 will be copied to the analog output 00. When we trigger the PNP proximity switch, digital input 1 is turned on and the first pilot lamp is turned on. That can be seen from the ladder diagram as well. Then we trigger the NPN proximity switch, which is linked to the digital input C4. And the second pilot lamp is turned on. The green one is turned on when the sensor is triggered on. And the digital output 01 is turned on in the ladder diagram. When we trigger the sensor 5 times, the green lamp should turn on 5 times, and then the blue lamp should turn on. Blue lamp is linked to the counter and the timer output. So we can see here the second digital output is turned on, which is connected to the output of the timer. Now we can adjust the analog input so that voltage is copied to the analog output. The voltage is shown in the multimeter. When we adjust in the potentiometer, you can see that the input and output of the analog is updating. Let's recap what you have learned in this session. You have learned how to power the PLC using the plus 24 volt and minus 24 volt. And then you have learned how to wire the digital and analog inputs using NPN type and PN type sensors. And then you have learned how to wire the digital outputs using sourcing outputs to power the pilot lamps. Then you have learned how to write a simple ladder diagrams using basic function blocks, contacts, and coils. Then how to download your program to the PLC and go into run mode, and then you can live see how the parameters are updated based on your inputs and outputs. Then we have tested this code in the lab environment and visualize how the inputs and outputs works based on the program specifications. So that ends this session, and thank you very much for participating in another session in industrial automation.